Okay, so good morning. Today we are going to do a single class where we are going to discuss Laplace transforms and whatever till date questions have come in Laplace transforms that we are going to study. There are not many as such questions which have come. Most of them are formula based, given your CSIR NET or GATE exam. So most of them most of these examinations, if you see there, we have most of them have this kind of direct formula based kind of question. Okay, so that is one part. The another part is that in this lecture itself, what I'm going to do is I'm going to start with these things like easier things, and then I'll go all along. Okay, then I'll go all along. Just give me a minute. I'll wait for people to join in, and then let us start. Okay, so on the very first day when I was teaching Laplace transform in the previous lectures, you might have seen that the first thing that is required. So this particular lecture is goes through what we have done till now, and today we are going to study all the PYQs. Okay, so what did you understand that the Laplace transform of a function ft is defined as 0 to minus infinity integration f minus st ft dt. This is how you define your Laplace transform. Okay, and provided that this particular integral should converge. This particular integral should converge. Okay, this particular integral must converge. And what were the conditions before? So condition number one was your function ft must be piecewise continuous on 0 to infinity. There were two conditions which was assigned to it. One was that your function ft must be piecewise continuous function. So I'll write here ft must be piecewise continuous function. And secondly, ft must be of exponential order. Must be of exponential. These two things were importantly suggested when I was giving you the lecture. Okay, so these two things are very important. Now, uh, if I go ahead and let's say, okay, just give me a minute. Okay. Now, if you see, and for the most elementary functions, we have till now, for most elementary functions, we discussed how to find the Laplace transform. For most elementary functions, we discussed how to find we discussed how to find the Laplace transform. We have discussed it. So for example, for 1, for cos, for sine, for exponential, we've already discussed how to find the Laplace transform. Okay, so this is something that we have already done. Okay, this is something that we've already done. Now see, today what is my target? Today we are going to revise this particular topic. That is, first, there are twofold objectives that I have in mind. One is to revise this entire topic, and secondly, to do some of the PYQs that have come in the examination, so that you will find that what is the level of study and how things have been asked. So, and another thing that I'm going to do, I'm just going to list a few of the Laplace transform that we have already found. That is the elementary function. This was 1. This was 1 upon s minus of a. Then Laplace transform of cos at was simply s upon s square plus a square. Laplace transform of sine at was simply a upon s square plus a square. Then I think Laplace transform of t raised to power n in general if n is greater than -1. And here you all remember what I have written here. The condition for existence of Laplace transform of 1 is that s must be greater than 0. Here the condition for Laplace transform must be s greater than a, and all these conditions we have already discussed. And here the Laplace transform should be gamma of n plus 1 divided by s raised to power n plus 1. So these are all those Laplace transforms that we have already done in our previous lectures. Okay, so these are the elementary Laplace transform of elementary functions. Now today's task, as I told you, is to revise the subject and again do some PYQs. Okay, this is the first thing that we are heading on to. Okay, another thing that we have done, we've also found how to find the Laplace transform of unit step function. Okay, so if you have to find the Laplace transform of Heaviside unit step function, so for example, if I say that Heaviside unit step function, let's say it is h of x minus of a, then the Laplace transform of h of x minus of a is simply e to the power of minus as divided by s. This is something that we have already done. I'm just trying to redo all these things. I'm just trying to make you memorize all these things. That these are all things that we have already done. Okay, and let us now try to develop a few more. Instead of developing a few more things, let us start to do some of the questions. So let us start to do questions, and which is an ideal way of revising a concept. An ideal way of revising the concept. Okay, so okay, so just try to find me the. I'm writing here. Just try to find me the Laplace transform of this function ft given by sine 2t, t lying between 2 pi to 4 pi, and 0 otherwise. Just try to do this. I'm giving you a minute, and then we shall. Okay, so see how to do this question. Just think about it. Okay, just think about it. That if I want to write this particular expression in one go, what I'll do, I will try to use. The Heaviside unit step function as given. I will try to use Heaviside unit step function as given above. So what I'm going to do, let's just see what is Heaviside unit step function. Let us first define that. So if I'm writing h of t minus a, what does it imply? It implies for all t greater than a, this is 1, and for all t less than a, it is 0. Okay, this is 0. So if I want to write this particular expression in terms of Heaviside unit step function, I will write what? See, I want somehow that my sine 2t survives. I want that somehow my sine 2t survives. So I'll write t minus of 2 pi. Why? Because for all t less than 2 pi, this would be 0. For all t less than 2 pi, this would be 0, isn't it? And for all t greater than 2 pi, it would be 1. But we also want that beyond 4 pi, my function again should be 0, because here what it is written, here it is written that your when t lies between 2 pi to 4 pi, your function should be sine 2t. So I'll write minus of h of t minus of 4 pi. This is so now you can clearly see. Now I'm just trying to write it all over again. See, just think about it. I'm writing it here. Now if your t lies between, t is less than 4 pi and is greater than 2 pi. So if t is greater than 2 pi, this term will be 1, this term would be 0. Fine. So answer would be simply sine 2t into 1 minus 0, which is sine 2t. If t is less than 2 pi, if t is less than 2 pi, this would be 0, this would be 0, so this would be simply function would be 0. And if t is greater than 4 pi, then this first term should be 1, this term should be 1, answer would be 0 only. Answer would be 0. So one has to understand that this is how you write the definition of a function using unit step function. So this is something that we have done. I'm just trying to revise it for you. Okay. So now try to find the Laplace transform for this. Now let us try to find the Laplace transform for the same. Okay. Is that clear or not clear? Now this brings us to another concept which is called as shifting property. Okay, this brings us to a new thing called as shifting property. So if Laplace transform of ft is fs, that is, if I am saying that my Laplace transform of ft is what? Laplace transform of ft is simply integration from 0 to infinity e to the power minus st ft dt, right? This is your Laplace transform. It is equal to f of s. Then what one can do, if one wants to find the Laplace transform of h of t minus of a, that is a Heaviside unit step function, multiplied by f of t minus of a, then it is simply equals to f of s minus of a. Precisely this is called as your sorry. It is equal to what? It is equal to e to the power of, sorry, my mistake. It is equal to e to the power of minus of as into f of s. This is called as your second shifting theorem. So this is called as your second shifting theorem. I'm just memorizing you all those things which we have done till now. So this is called as second shifting theorem. This is called as second shifting theorem. Just memorize it. Okay, just memorize it. Now you see what you have to find. You have to find the Laplace transform of ft. You have to find the Laplace transform of ft, where ft is what? Ft is simply sine 2t into h of t minus 2 pi. So what I'll do, I have to write f in the argument of f must be similar to that of argument of the unit step function. So what I have to do, see, again remember, I have to make the argument of function and the unit step function the same. Okay, so argument of this is t minus 2 pi. Now remember, sine 2 pi minus t is what? It is equal to minus sine t. So instead of that, I will write sine of t minus of 2 pi, because now sine of t minus 2 pi would be simply sine of t only, right? So what I'll do, okay, what I will do, I will simply write it as sine of this is t minus of 2 pi into h of t minus 2 pi minus, again same, this thing I can write sine of t minus 4 pi into h of t minus 4. Okay, in fact you should remember that sine 2n pi minus t is equal to simply sine t. So whether it is sine 2 pi minus is minus sine t. So whether it is sine 4 pi minus t or sine 2 pi minus t, it is going to be minus sine t. So you can write t minus 2 pi. So instead of that, you can write this way. Now you see this particular Laplace transform of ft would be equals to what? It will be Laplace transform of sine t minus 2 pi into h of t minus 2 pi. So according to this second shifting theorem, the answer should come as e की power of minus of 2 pi s, e की power of minus of 2 pi s, and then what I'll get, just have a look at on this, into Laplace transform of sine. What is this? Fs is what? F is the Laplace transform of the function. What is the Laplace transform of sine? Laplace transform of sine is simply s upon s square plus, so there was some sine 2t, no, sorry, sine 2t भी तो था, so you have to write sine 2t. So it was sine 2t, right? Sine 2t. It was sine 2t, if I remember right. It was sine 2t. So what I'll do, I'll simply write sine 2 2 pi minus t will be sine 4 pi minus t. Again, it will be the same thing. And whether you write sine 2 t minus 2 pi, this will also be like sine 2t only. Is that clear? Okay, sorry. So now what is this? This is Fs is simply the Laplace transform of sine 2t. The Laplace transform of sine 2t is s square, s upon s square plus 4, and this is minus e की power minus of 4 pi s upon s square plus 4. So eventually this Laplace transform will come out as, I hope it is clear. I hope it is clear. Okay. Okay. Now let us take another question and progress. Okay. Let us take another question and progress. Okay. So I hope it is clear. So my, again I'm telling, my only objective with this particular session is to actually revise all the concepts that we have done till now. Okay, so I've revised the second shifting theorem till now. I have revised to you what is the Heaviside unit step function and what is the Laplace transform of this particular function. Uh, okay, now I'm going to I'm going to do another question for you, and then we are going to see how the questions are asked in exams, so that you'll feel positive about it. Okay, now try to do, find the Laplace transform of ft, where ft where ft is given by this. I will write t minus 1 for all t lying between 1 and 2, and if t lies between what, 2 and 3, then it is equal to 3 minus of t. Okay, so now if you want to find the Laplace transform of this particular function with the function such that for all t lies between 1 and 2 it is t minus n, and for all t lies between 2 and 3 it is 3 minus of t, then what will be the Laplace transform for this particular function? What would be the Laplace transform of this particular function? So see, again, I told you in the very first class itself that one needs to express the Laplace transform. One needs to express prior to the Laplace transform ft in form of Heaviside unit step function, or in terms of in terms of unit step function, Heaviside unit step function. So let us do that. So ft is what? So what I'll do, I have to somehow write my function in a manner that my t minus 1 is defined only for this thing. Again, confirm whatever I'm writing. See, a unit step function means what? So if I write h of t minus 1, what does it mean? It means it is equals to 1 if t is greater than 1, it is equal to 0 if t is less than 1. And similarly, if I write h of t minus 2, what it is? It is equals to what? It is equals to 1 if t is greater than 2, and it is equal to 0 if t is less than 2. ठीक है. So अगर if t is less than 1, if t is less than 1, this would be 0, this would be 0. If t lies between 1 and 2, this would be 1, this would be 0, you will get t minus 1. And if t is greater than 2, this would be 1, this would be 1, overall it would be 0. So here we have to use this kind of definition. So what I'll do, I'll add plus 3 minus t, and then I will write what? I will write h of t minus 2 minus of h of t minus of 3. So this is how I write my function. This is how I write my function. I hope it is clear. Now, if I am supposed to find the Laplace transform of this, I told you on the very first, I told you prior to this particular question that I have to somehow, when I have to use my second shifting theorem. So here I am writing what is my second shifting theorem again. The second shifting theorem suggests me that Laplace transform of f of t minus of a into h of t minus of a, it is simply equals to what? It is simply equals to e की power of minus of as into capital Fs. So this is how it is. So in order to write this way, one thing that is very much sure, I will have to somehow place all these things in, like for example here t minus 1, here it will be t minus 1, but here you see there is t minus 2. In the second term, if you see there is a t minus of 2. So I will have to arrange all these terms, and then I will have to make certain thing. I will have to write in that fashion. Is that clear? So here if I just add these terms up, so here we have this t minus 2. So first term is fine, is t minus 1 h of t minus 1. This is absolutely fine, there is no problem regards this. This is my t minus 1, but so I'll write plus, I'm writing h of t minus 2. Okay, I'll write h of t minus 2 here, and then you see here there is a t minus 1, so I'll write t minus 1 with a negative sign, so this will be 1 minus t, and then plus 3, and then I think this is again minus t. So I have added this term, and I have added with a negative sign this term. This will give me ht minus 2, and then I have minus minus, I will write simply plus, this would be t minus 3 h of t minus 3. Now I'll write my function ft completely, which is equal to what? It is equals to t minus of 1 h of t minus of 1 plus, here you see 3 plus 1 is 4, minus t is 2, so I'll write what? Common, I'll take 2, it will be 2 minus of t, or I'll take a negative also here. So if I take a negative also here, then what I'll get? It will be t minus of 2, and then I have this h of t minus of 2 plus t minus of 3, and then again h of t minus of 3. Now you see, if I want to take the Laplace transform of this particular function, if I want to take the Laplace transform of my function ft, it will be equivalent to what? It will be equivalent to writing Laplace transform of t minus 1 h of t minus 1 minus 2 Laplace transform of t minus 2 into h of t minus 2 plus Laplace transform of t minus of 3 h of t minus of 3. Okay, so this is one thing. And if I write this way, what will be this? Again, compare the two, like you use the second shifting theorem, and now you can clearly write it would be equals to what? It will be equals to e की power minus s upon s square Why s square? Because Laplace transform of t. Just remember this is t minus 1. So f of t minus 1 is t minus 1. So f of t would have been t. So the Laplace transform of t is s square minus 2 e की power minus 2s divided by s square plus, or I think there was a minus somewhere or what? Okay, plus e की power minus 3s divided by s square. So this would be an answer to this. So all these, whenever you have this kind of piecewise continuous functions defined, one of the ways, so I'll write it here, whenever you have, this is a concept that I'm writing here, whenever you have piecewise continuous function, then try to employ heaviside unit step function. Try to employ heaviside unit step function. Try to employ heaviside unit step function. This is one thing that you should understand. And this is what I have illustrated by these two examples. So as promised, I am doing all these things just in order to revise the entire Laplace transform. The entire Laplace transform I want to revise for you, so that at least if you've not done it in the previous classes, you can do it in this particular lecture. In one entire lecture, I want to complete it off using your previous year question and some questions that I'm going to give you from my own like from right now. Okay, so this is what I'm aspiring to do. Okay, chalo. One more question let us try to do. So in this question, try to find me the Laplace transform of t square minus t plus 2 into h of t minus 2. How to find it? So as I told, here you have h of t minus 2. I'll try to write each of these things in terms of t minus 2. So this is t minus 2 whole square. Then this will give you t square minus 4t plus 4. So this will give you plus 3t minus of 2. So what we will get, 4 minus 6, this is minus 2. And then you have to mend it, so I'll write plus 4 as well. So I'll write plus 4 as well here. And this is h of t minus 2. Okay, so this is how you write your Laplace transform. So Laplace transform of t minus 2 whole square, h of t minus 2, then plus 3 times t minus 2 into heaviside function at t at 2, then plus 4 times h of t minus 2. Is that clear? Now if I want to write the Laplace transform of this will be equal to e की power of minus 2s into 2 upon s cube. Why 2 upon s cube? You have to remember this, that you have to take the Laplace transform of t, like t square here, because this is what this is. I'm writing it here. This is what this is, f of t minus 2. So f of t minus 2, if I'm writing it is t minus 2 square. So what is the structure of function? Structure of function ft is simply t square. Structure of function is simply t square. So you will get e की power minus 2s into 2 upon s cube plus 3 times e की power minus 2s divided by s square, and then plus 4 e की power minus 2s divided by s. So after all, I can write this as e की power minus 2s times 2 upon s cube plus 3 upon s square plus 4 upon s. So this is how you write your Laplace transform. Okay. Okay. So till now, I think it is quite clear how to use. So far we have understood how to use Heaviside function in formulating the definition of piecewise continuous functions. And then we have taken the Laplace transform using the second shifting theorem. And also we have till now done how to find Laplace transform and use of second shifting theorem. This is what we have, this is what is our learning till now. Okay, so how to use second shifting theorem, this we have done. Okay, and so these two things we have done till now. Now let us extend our discussion to something called as convolution theorem. So next in the line comes convolution theorem. And if you remember, what did I tell you about this theorem in previous lecture? I'm going to just write the statement. I have derived it, but I'm going to just write here the statement. So if f and g possesses Laplace transform, if their Laplace transform is well defined, then the Laplace transform of the convolution of f and g, which is nothing but Laplace transform of integration from 0 to t f of x into g of t minus of x dx, is simply Laplace transform of f into Laplace transform of g. This is how you define your convolution theorem. Okay, this is how I define the convolution theorem. So what does it say? It says that this Laplace transform, this particular integration, which is supposedly known as your convolution of f and g, is nothing but product of individually the Laplace transform of f and Laplace transform of g. So this is an important theorem which is called as convolution theorem, and let us revise it using one question. So let us revise it using one question. So question is, find me the Laplace transform of integration from 0 to t minus z ka whole square sin z dz. I have to find the Laplace transform of t minus z ka whole square sin z dz. Okay, this is what I have to do. Okay, how to do it? See, it is equal to writing here f of t minus z. So here I can write, from comparing the two, compare both of them, you can write that your f of t is simply sin t. From here you can see that your f of t is simply sin t. Yes or no? This is quite easy to see. It is quite easy to see that your f of t is simply sin t. And what about g of t? So instead of gt minus x, here it is t minus z ka square. So I'll write my gt is simply t square. So this the Laplace transform of this convolution is simply Laplace transform of fs as a Laplace transform of f into Laplace transform of g, which is equivalent to writing Laplace transform of f is what? It is 1 upon s square. Here it is here it is 1 upon s square plus 1 into what is Laplace transform of t square? It is equals to 2 factorial divided by s cube. So the Laplace transform of convolution of this particular two functions, that is f and g, is simply 1 upon s square plus 1 and 2 upon s cube. So this is how you can use the convolution theorem to find these kind of Laplace transform. So this is an important thing when it comes to your what I can say, when it comes to your Laplace transform theory. So one has to remember this theorem, which is called as the convolution theorem. One has to remember this kind of theorem, which is called as the convolution theorem. I hope it is clear till now. Then further, when we were studying, we also studied how to find the Laplace transforms of a periodic function. How to find the Laplace transform of a periodic function? So how to find it? That we have to see. So if my function ft is a periodic function, with a fundamental period omega, then the Laplace transform of ft, and such that it obviously the Laplace transform is defined. So all the conditions, whenever I'm writing the Laplace transform, it obeys the conditions of let's say that function being of exponential order and ft being piecewise continuous. So all those conditions, if it is abiding by, then the Laplace transform of this periodic function is given by 1 upon 1 minus e की power minus of s omega integration from 0 to omega e की power minus st ft dt. So this is the Laplace transform of the periodic function. Okay, this is the Laplace transform of periodic function. This is the Laplace transform of the periodic function. Okay. Now you see, I'll give you a question and then try to do that question. Then I'll move ahead for further things to do. Okay, try to do this question which I'm giving you right now. Find me the Laplace transform of function which I'm going to state right now. You have to find me the Laplace transform of ft, where ft is defined by k small t divided by capital T if t lies between 0 and capital T, and f of t plus capital T is simply f of t. So the condition for periodicity is defined. So I can say that my function, from here I can say that my function is periodic with period t, and the definition of the function is k times small t divided by capital T. You have to find what would be the Laplace transform of this particular function. Okay, so how to find it? So this is one thing that that is my query right now. So how to go about it? So I have already written, and again I need to reiterate the objective of these lectures. In this lecture, what I'm trying to do, I'm trying to revise whatever has been told till now in the Laplace transform, and then I'm also going to do some of the PYQs so that you remain you should understand that what is the level of the questions and what is the level of training that we have got so far. Okay, so this is my objective in this particular lecture. So don't worry if you don't know these things. At least whenever I'm writing the formula, try to jot down those formulas in your copy and then try to solve it. Okay, then try to solve it. I think it will be quite easy for you in that particular case. Okay, so this is what I suggest, right? This is what I suggest, right? Okay, just give me a minute. Okay. So now, how to go about this particular problem? So you know that your function is given to be periodic function, and I have written what would be the Laplace transform of the periodic function with fundamental period omega. So here in the question itself, it was given that your function f t is kt upon capital T, and where t lies between 0 and capital T, and your function f is periodic with fundamental period capital T. So whenever if you write f of t plus capital T is equal to ft, it implies that your t is the fundamental period. It is the fundamental period. So period of function is capital T here, and you're given that your function ft abides a definition, or you can say that it follows a definition which is k times small t divided by capital T. So using the above theorem or using the above result, what I can do, I can simply write that my Laplace transform of k times small t divided by capital T, which is that particular function, is equal to 1 upon 1 minus of e to power minus of s and capital T here. By capital T, because instead of omega you can write capital T, integral from zeros to capital T e to power minus of st, then you have this kt divided by capital T dt. I hope it is clear. And now it is very simple to do. What you have to do now, you can simply see that you just take capital K, small k and capital T outside. This will be 1 minus e to power minus s into capital T, and this integration would be what? It will be t e to power minus st divided by minus s minus integration. The derivative of t would be 1. Integration of e to power minus st would be e to power minus st divided by s. So this would be 1 upon s. And I have to place limits that I'll do, don't worry. Now what it will be? So Laplace transform of your given function f of t, which is kt divided by capital T. It is k divided by capital T 1 minus of e to power of minus of s capital T, and then this is like minus t e to power minus st divided by capital S, and the derivative again. So you'll take minus 1 upon s integral again. This will be, and what I'll do, I'll take this negative out. The upper limit I'll place 0 and the lower limit I'll place t. Okay, if I take this negative and if I interchange the limit instead of that. Okay, so if I interchange the limit, if I place 0 here, it will become 0, and if I place t here, so what I'll get k capital T 1 minus e to power minus s capital T, and if I write this, it will be minus t and then you have this plus okay, and if you place 0 here, so you get so eventually what I will get Laplace transform of ft as simply this would get cancelled obviously. So I'll get an answer as minus k power minus st divided by s 1 minus e to power minus st plus this 1 minus e to power minus st would get cancelled. This is k upon capital T into s square. Okay, so this is how you write your Laplace transform. So again, I'm reiterating the objective. The objective of this lecture is to do on each of these topics one question, so that you get acquainted with that formula, and then we'll try to do the previous question also. Now, if I correctly remember, there was a question in the examination itself, so I'm going to do that question also for you. If I correctly remember, just give me a minute. So here you are. This was the question. I'm going to write it for you. So this particular question was asked in NET exam only. This particular question was asked in NET exam of 2012. And the question says that the graph of function is made in this way. Okay, this is how it was made in the exam. So it is 0, it is 1, it is 2, it is 3, it's 4, it's 5. And I'll write here that you have f of x is equal to 1 if x lies between 2n plus 1, and is equal to 0 if x lies between 2n plus 1 to 2n plus 2. So this is your question. This was asked in NET examination of 2012, and one needs to find the Laplace transform of this particular function f of x. One needs to find what will be the Laplace transform of this particular function f of x. One needs to find what is the Laplace transform of this particular function. So how to go about it? How to go about it? So this is clearly a periodic function. This is clearly a periodic function. I think with a period of 1, that is f of x plus 1 is simply equals to f of x. And if I want to find the Laplace transform of f of x, it will be equals to what? It will be equals to 1 upon 1 minus e to the power minus s. I think this was the formula. We just use this formula. Okay, sorry. Okay, let's try to do it in a manner where अच्छा एक काम करते हैं फॉर्मूले से करते हैं एक मिनट my mistake. Okay, so I'll write the formula first so that if people have joined it just now, so that at least they'll remember the formula. So formula says that if your function is periodic with period t, the Laplace transform of f is simply 1 upon 1 minus e to the power minus st, and integration from 0 to t, and that is f of the here formula e to the power minus st ft. I hope it is clear now. I'm giving you a minute. Try to use this formula and then try to do it, and then I'll do it for you. Okay, so I'll do it for you, don't worry. So see, I was writing it is periodic function with period, sorry, 2 see, देखो ये फंक्शन थोड़ा ध्यान से देखो, इस फंक्शन को थोड़ा ध्यान से देखो, how that how this function is going. So if you see, this particular function is going this way, so you just see the tendency of the function. So function goes like this and then it goes to 0 and then again function rises from here and again it follows the same pattern. Okay, so this particular pattern which I'm writing from here to here is a repeated pattern, right? So this pattern gets repeated, so this entire pattern gets repeated. Not only this, 0 is also getting repeated, right? So not only this, 0 is also getting repeated. So your fundamental period of the function, so if I make it in a different pen so that you are able to get it, here it was 1, then again it gets to 0. So this entire pattern which I'm writing right now, this is getting repeated and this is getting repeated in an interval of 2, in a distance of 2. So I can write that here the fundamental period of the function, the fundamental period of the function is 2. So if I use t equal to 2, what I'll get 1 upon 1 minus of e to the power 2s integration from 0 to 1, because from 1 to 2 it will come as 0 to 2 only, but understand from 1 to 2 it is 0 only. So I'll eventually have to integrate from 1 to 0 to 1 only, e to the power minus st. ft is what? Ft, let me write first ft and then I'll see. Now from 0 to 1 it is 1 and from 1 to 2 it is, so I'll get e to the power minus 2s integration from 0 to 1 e to the power minus st. This will be 1 plus 1 to 2, this is 0. So forget about this integration. Forget about this integration, not needed. It will obviously go to 0. So only this integration going to survive. And what will be an answer to this integration? I think if you remember, integral of e to the power minus st would be what? It will be minus 1 upon s. So I'll write 1 upon s only here. I'll write 1 upon e to the power minus 2s here. And e to the power minus st, I'll reverse the integral limits to compensate for that minus. And eventually what I'll get, this Laplace transform of this particular pattern, or you can say function or periodic function, whatever suits you, is equals to 1 upon s 1 minus e to the power minus 2s into 1 minus e to the power minus s. If you cancel this 2, you will get 1 upon s into 1 plus e to the power minus s. So this is, I think, answer to this particular question. Okay, so excuse me for the result that I initially wrote, because see, if we remember these blocks but we forget this also. So actually function in entirety, if you see, from 0 to it is behaving, from 0 to 2 it is 1, from 0 to 1 and again 0, and then again it rises and again it's 0. So actually this entire pattern is getting repeated, right? So one has to remember that the period of this particular function would be actually t equal to capital 2. That is, the fundamental period of this particular function is 2. And so if you use this particular formula, then you can do. You could have used other ways also, like you can use Heaviside function also. This is something that we have discussed in the detail in lectures taken before also. But I think this would be more the most convenient approach in your exam. Is that fine? If anybody is listening to the live lecture, kindly let me know so that I should move further. If there is some doubt, then I'll stop. So I'm waiting for a minute. If somebody has a doubt, then please let me know in the lecture. Otherwise, I'll move forward. Okay, chalo. So this is one of the previous year question. Now let us again divert our attention to the revision side. So till now, what we have done the Laplace transform of periodic function. Yes. Then we have also done the convolution theorem, the revision of convolution theorem. Then we have done how to use the piecewise continuous function and use the second shifting theorem. Okay. Then we've also done, I have written some of the uh, initial, like some of the elementary transforms. Okay, and I've also stated that how that particular function, if the Laplace transform has to exist, what are the prima facie conditions uh, that one should remember. Okay, so till now we have done all these things. Now let us again go back and focus our attention to simple things. So few more things that one needs to remember. A few more things that one needs to remember. Okay. Okay. Am I audible? Uh, am I audible right now? Actually, the power went off now. So I hope am I audible right now? Okay, I hope I'm audible right now. Uh, just let me know if I'm audible, if I'm not audible. Uh, am I audible right now? Okay, I hope now I'm audible. So actually, there was a power cut because of which I had there was a break in network connection. Now I'll again resume back to the lectures. Okay, I'll again resume back to the lecture. Okay, so one thing is very much sure that I have done much of it. These things we have done. Now try to find. See, another important theorem than what needs to remember is called as the first shifting theorem, or simply you can say this is called as first shifting theorem. I'll write it here. This is called as first shifting theorem. And what does it says? It says that once you know that the Laplace transform of your ft is simply capital Fs, let's say your Laplace transform of capital Ft is capital Fs, and then if I want to find the Laplace transform of, sorry, if I want to find the Laplace transform of uh, e to power at into ft, then it will simply be the f of s of minus a. This is how you write the Laplace transform. So this property is called as your first shifting theorem, or you can say translation theorem. So what happens is, if you multiply your function by e to the power at, and then if you want to find the Laplace transform, it will simply be equals to f of s minus a. So your Laplace transform has translated in the s space. Okay, your Laplace transform has translated in the f space. So this is an important theorem again. Most of the times in exam, questions come from this particular theorem also. So let us do a few more questions here, and then we'll move ahead. So let us try to do a few more questions. Let's say the question is, find me the Laplace transform of, find me the Laplace transform of e to the power minus 2t into t square. Find me the Laplace transform of e to the power minus 2t into t square. So you have to find this particular Laplace transform. How would you do? So can see, one can see that, see, if you use this particular theorem, so here a is what? A is here minus 2. So you can write that a is minus 2 here. What would be Laplace? What would be the Laplace transform of t square? The Laplace transform of t square is simply f of s, and which is equals to what? It is equals to 2 upon s cube. And if I use this, what I'll get? I'll get this Laplace transform as 2 upon s plus 2 ka whole cube. 2 upon, sorry, 2 nahi. There is a 2, there is a 2 already there, and sorry, 3 factorial. So what is the formula? Laplace transform of t ki power n is simply n factorial, sorry, n factorial upon s ki power of n plus 1. So it will be 3 factorial divided by, so this will be s 6 upon s plus 2 ka whole cube. Is that fine? So this is something called as a first shifting theorem. We have done it, so I've made you revise it. Now try to do another question on this only, so that it gets in your head how to use these theorems. This is called as your first shifting theorem. So remember, this is an important thing to do. This is an important thing to do. So what would be the Laplace transform of e ki power t into sine 4t? I'm just giving you a minute. Try to do it in your register right now, and just then we'll discuss. So here in place of a, you can see it is 1. What is Laplace transform of sine 4t? It is simply 4 upon s square plus 16, right? It is 4 upon s square plus 16. This is the Laplace transform of sine. See, it is multiplied by e ki power t. So by using the first shifting theorem, what you can write? It will be Laplace transform of e ki power t into sine of 4t would be simply 4 divided by s minus 1 the whole square plus 16. So this is how important is your first shifting theorem. Now let us move ahead and do one more property that we have done, and then we'll see how to utilize that property. So the property says, the property is about the derivatives. So now if I have to find the nth derivative of my, this is another property like the derivative of the Laplace transform. So this is like derivative of the Laplace transform. So if I have to find the nth derivative of my fs, it is equals to d by dt of, or this is equals to Laplace transform of minus 1 raised to power n t raised to power n f of t. So this is how, this is the property where I have actually differentiated my okay, sorry, I think there was a connection error. Okay, so yeah, so what we were discussing the derivative property, where the derivative of fs, the nth derivative of fs, yeah, so the nth derivative of fs is given by Laplace transform of minus 1 raised to power n t raised to power n into f of t. So that will give you the nth derivative of your f of s. Is that clear? I hope it is clear till now. So again, because a few people may have joined, so today's what we are doing today is we are trying to revise our topic using questions and using the previous year questions also. Okay, so the nth derivative of f of s is given by Laplace transform minus 1 raised to power and t raised to power f of t. Now just try to find me the Laplace transform of, let's say, what it would be. So I'll give you a question and then we'll see. Try to find the Laplace transform of t square e to power t sine 4t. So we have done the Laplace transform of e to power t into sine 4t. Just try to find this. Okay. So from the above result, I know that Laplace transform of t square into ft would be simply what? It will be d2 upon ds2 of your f of s. And see, Laplace transform of e to power t sine t you have calculated right now, which is equal to this. Now all you need to do is you need to find the double derivative of this particular function, and create the double derivative of this particular function. You can find, so the first derivative of this particular function, d by ds of this entire thing would be what? It would be minus of 4 upon s minus 1 का whole square plus 16 का whole square into 2 times s minus 1, and then again take the derivative of the same. So you have to take again the derivative, and I'm just writing the answer. You just have to verify it. It will be equals to what? It will be equals to 24. It is a long thing to do, so I'm leaving this to you. Minus 2s minus 4s divided by s square minus 2s plus 17 का whole square, a whole cube, sorry. This is what you get. Okay, so this is one thing that you need to remember. Okay, so again I'm reiterating, the objective of this class is to make you revise all the topics at once. Okay, probably I'll take another live session where I'm going to just discuss precisely the Laplace transform and the differential equation, but today's lecture is mostly on finding the Laplace transforms and inverse Laplace transforms of some elementary functions and some of the questions that have been asked in the examination. Okay, so I hope it is clear till now. It is clear till? So one of the techniques that one need to remember, again an important thing to suggest, one of the important technique which becomes handy while evaluating a Laplace transform of an integral is the change of order of integration. So if your function, like whichever functions are involved in the double integrals, if they are continuous, then you can change the order of integration to make it more feasible. Change of order of integration. So let us do one of the questions, and then I'll let you know what I want to suggest. So understand, this particular thing is quite important for you. That is a change of order of integration. And so for example, I give you an example. Let's say I want to find the Laplace transform of, let's say, this function f of t, which is given by integration from 0 to infinity sine tx divided by x dx. Let us say this is my function, and if I want to find the Laplace transform of this particular function, how would I do? So it would be equal to writing the Laplace transform of ft, which is equal to what? It is equal to the Laplace transform of integration from 0 to infinity sin tx divided by x dx, and which is equivalent to writing 0 to infinity e की power minus st integration 0 to infinity sin tx upon x dx dt. Okay, now you see it would be very good, because see, this integration for evaluating this particular integration, I will have to use complex integrals, right? If you remember, this is a sort of a Dirichlet function, Dirichlet integral. We've done it already, but I'm not going to do that. I'm going to change the order of integration. I'm going to change the order of integration. So instead of integrating first with respect to x and then with respect to t, I'll sorry, I'll integrate first with respect to t and then with respect to x. So Laplace transform of ft on change of order of integration would yield me e की power minus st, and then I have this the sin tx, and then 1 upon x will be here. I will integrate first with respect to t and then with respect to x. So I integrate first with respect to t. What are the functions which depend upon t? These are the function e की power minus st into sin tx, and then I will integrate with respect to what, beta? Then I will integrate with respect to x. Is that clear? So in other words, what I'm going to do, I'm going to integrate first with respect to t. So I'm writing a bracket smaller here. This is e की power minus st, and this is sin tx dx, and then I'm going to integrate with respect to x. So first I'm going to integrate with respect to t, and then I'm going to integrate with respect to x. So this is how the change of order of integration will help you, because see, if you integrate this thing up, so eventually if you want to do it, you can do using complex integrals also, but right now I'm interested in using the less difficult approach. So let's do that. What would be this integral? This integral we have evaluated quite many times. This will be integration. I'll do it for you now. यहाँ पे करते हैं इसको. Integration 1 upon d e की power minus st sin tx, or you can say this is simply the Laplace transform of sin tx. What is Laplace transform of sin tx? So it is like whatever is multiplied with this, so x upon x square plus t square okay, this will be what? This will be x upon x square plus t square, and then I will write dx. So x would get cancelled. What is the answer for this? The answer for this would be, okay, sorry, s is there, no? So it will be 1 upon s square plus c e की power minus st sin tx dt. What is this? This is the Laplace transform. I'll write here. It is the Laplace transform of what? It is the Laplace transform of at की जगह क्या है? xt. So this will be x upon s square plus x square. So this is what I'm going to write. And now what is this? This is 1 upon a tan inverse of x upon a. From where to where? From 0 to infinity. And if I have to write what is the Laplace transform of your ft, so Laplace transform of your ft is simply what? It is simply pi upon 2s. Okay, and if I want to find what is the value of this integration, I need to find ft. So which is equivalent to writing what? Which is equivalent to finding the Laplace inverse of same. So I'll use Laplace inverse. I know that Laplace inverse of 1 upon s is simply 1. So what I'll get, if I use the Laplace inverse here, I'll get pi upon 2. Is that clear? And this is for all t greater than 0. So I'll write it here. It is for all t greater than 0. If t is less than 0, then it will be accompanied by a negative sign. If t is equal to 0, then this will be accompanied by a negative sign. And if t is less than 0, if t is less than 0, it will be accompanied by a negative sign. And if t is exactly equal to 0, then this will be 0. So what you can do, you can try to write this entire definition ft equivalent to pi upon 2 if t is greater than 0, equal to 0 if t is equal to 0, and for t less than 0 it is simply minus pi upon 2. Or in other words, I can write this entire thing equals to what? I can write this as pi upon 2 2 times h of t minus 1. I hope it is clear. I hope it is clear. Please let me know on the live if you are there. If somebody is there, kindly let me know on the chat box so that I can move further. So now let us do a question from JEST exam, and again it is an easy question. Okay, find me the Laplace transform of sin 80 minus a times t cos 80 divided by 2 times a cube. So if I want to find the Laplace transform of this particular function, how would I do? So this was asked in JEST exam. I think it was 2018. So one knows that the Laplace transform of sin 80 is very simple to do. It will be simply a upon, so I'm writing it here, the Laplace transform of sin is simply s square upon s square plus a square, and then there is 1 upon 2 a cube, so I'll write 1 upon 2 a cube. What about this? Here t is multiplied by cos 80. So if I remember, what would be the Laplace transform of minus t cos 80? This will be d by ds of the Laplace transform of cos 80. Okay. So which is equivalent to finding what? It is equivalent to finding the derivative of s upon s square plus a square. So what I'll write minus 1 upon 2a square here, and I'll take this negative. Laplace transform of t into cos 80 would be equal to what? It will be the derivative of s upon s square plus a square. This is what you have to find. So I think this will be 1 upon 2a square here also. And then you have this plus 1 upon 2a square here as well. And what is the derivative of this? The derivative of this will be 1 upon s square plus a square minus 2s square upon s square plus a square whole square. Now you can clearly find it. I think it would be easy thing for you to do. However, I'll help you out in finding the right integral. So 1 upon 2a square here, and this is 1 upon s square plus a square, plus just try to find this. This is s square plus a square whole square, and this is s square plus a square minus of 2s square. Eventually this is 1 upon, this is s square plus a square plus a square so you'll get what? You'll get 2a square will get cancelled. You'll get simply answer as 1 upon s square plus a square. Okay, so this was ours in JEST examination. So it's quite easy to see that it's fairly easy to see that these questions in examinations are not asked to that level we have achieved till now. We have done enough difficult questions than what has been asked in the examination. Okay, now let us do another question which has been asked in the, this question has been asked in the NET exam again, and it is NET 2016, in which year it was asked. It was sought that what is the Laplace transform of your ft, where your ft was equal to t upon capital T, and whenever your t is greater than capital T, then it is equals to 1. Now you need to find what will be the Laplace transform of this particular function. This is what was asked in the NET exam. So what you will get from here? So what is the Laplace transform? Laplace transform of your ft is simply 0 to infinity integration 0 to infinity integration of e to the power minus st ft. So it is equal to 0 to capital T. It is t upon capital T e to the power minus st dt plus integration from capital T to infinity and e to the power minus st dt. Okay, now one needs to write what will be this. So I think 1 upon t will go outside. The integration to this will be t into e to the power minus st divided by minus s. I'll change the limits of integration. So it will be from 0 to capital T minus derivative of t is 1. Integration of e to the power minus st is this. So I'll get minus minus plus and then plus 1 upon s square e to the power minus st from 0 to capital T plus again e to the power minus st upon minus s or simply s from t to infinity. Is that clear till now? And if you want to solve it, you will get what? You get 1 upon t, and here you are getting 0 minus t e to the power minus s capital T divided by s plus 1 upon s square e to the power minus st minus 1 upon s square plus e to the power minus st upon s. Then eventually you will get this t gets cancelled, minus e power s. This will give you 1 upon s square capital T into e to the power minus st minus 1 upon s square capital T. Is that clear? Or in other words, if I want to write, this will be 1 upon s square t e to the power minus of st have I made a mistake somewhere? Just see if the answer is wrong. 0 to t capital T, I have done the integral this. So integral of this will be t upon e to the power minus st upon minus s from 0 to 2 की जगह मैंने कर दिया 0 to capital T here. Here this integration would give me what? Minus, and the derivative of t is simply 1. And the integral of e to the power minus st would be e to the power minus st upon minus s. So there would be a plus. Achha, there would be a negative here. Sorry, my mistake. So there would be a negative here. So first negative, and again a negative. Okay, so sorry, my mistake. So there would be a negative here. I'm just removing this off. Okay, so there would be a negative here. Okay, so first negative, again two negatives. So I'll get a negative here. I'll get a negative here. if I get a negative here, okay, so this will become positive in that particular case. Okay, so what I'll get this plus and this negative, and if that is the case, I'll get this as negative, this as plus. Okay, so this will be 1 minus e to the power minus st divided by s squared t. This is going to be your answer. Okay, now try to find another question, and this will be probably the last question in today's series, and then we'll take one more lecture on the same same lecture like this only, live lecture, and then we are trying to we are going to do it. So it was asked in NET 2015, and the question was find the Laplace transform of 6t cube plus 3 times sine 40. You know, it's a very easy question for you to do. I'm leaving this particular question as an exercise for you. Try to do this question, and we shall meet in the next live lecture, probably a day after or probably someday. So another live lecture I'm going to teach you. In another live lecture I'm going to teach you the Laplace transforms again, inverse Laplace transforms, and how to utilize Laplace transform in differential equations. This will be the matter of discussions in the next live lecture. So I hope to meet you there. Till then, try to revise all the 8 lectures that we've done till now on Laplace transform. Provided this particular lecture, if you also go back and see, you'll be able to see that we've done enough of the revision, and then we are going to do much of different things so that we are well prepared for this year's attempt if certain things come out of the box. Okay, so till then, take care.